Hey everyone, welcome back. Let's look at another LeetCode daily challenge, and today's problem is permutation in string. Given two strings s1 and s2, return true if s2 contains a permutation of s1 or false otherwise. In other words, return true if one of s1's permutation is the substring of s2. Let's take the examples and try to understand the problem statement. Now in the first example, we have s1 as ab and s2 is EIDBA triple O. Now we need to check if any permutation of S1 is present in S2 or not. So possible permutations of S1 is AB or BA. Is AB present in S2? No. Is BA present in S2? Yes. So we return true. Okay, now that we understand the problem statement, let's try to break it down. Do we actually need to calculate all the permutations of S1 and check in S2? Not really. We just have to calculate the character count. Say for S1 the character count is A is 1 and B is 1. We just need to check for every substring, does the character count match with whatever we found for S1. Say for example, if we consider EID as a substring, what is the character count? E is 1, I is 1, D is 1. Does it match with whatever we found with S1? No. So we do not consider this substring. But what about BA? BA's character count is B is 1, A is 1. Does it match with whatever we found with S1? Yes, it does. So we have found our match and we return true. Okay, what would be the brute force approach? We generate all the possible substrings of S2, check its character count and compare it with whatever character count we found for S1. If it matches, we return true. If we do not find any match, in the end we return false. But generating all the possible substrings out of S2 would itself take order of n cube time. Given the input size, it will definitely TLE. Now can we do better? Do we actually have to generate all the possible substrings out of S2? No, we can actually think of a sliding window approach. Before we get into the sliding window approach, I want to highlight the skeleton that I follow while approaching a sliding window problem. We have two pointers in sliding window, one is I, one is j. I points to the start of the window, j points to the end of the window. We start by processing the current element, that is j, and then we start shrinking from the left, that is we start shifting I if a certain condition applies. We compute the result and finally we increment j. These steps will make more sense once we do the dry run. So let's do it. Now this is our original example. Let's create two maps to store the character counts of S1 and S2. Map 1 corresponds to character count of S1 and map 2 corresponds to character count in S2. So we pre-compute whatever is there for S1. So that is this. Now we have two pointers, I and j. I pointing to the start of the window, j points to the end of the window, and j is the iterator. We'll go step by step, starting with processing the current element which is pointed by j. We'll put it into our map. We'll move on to step 2. Now when do we shrink the window? When we have an extra character in map 2 which is not present in map 1. That is when we shrink. We do not want extra characters. So we'll start shrinking the window. We'll remove the character whatever is present at I and we'll increment I. So I points to E, so E goes to 0. We decrement that and we move on I to the next index. So step 2 is done. Step 3 is compute result. This is nothing but comparing the two maps. If both the maps are identical, we return true, which is not the case. So we move on to the next step, that is increment j. We'll increment j to the next index. Now again, starting from the first step, we process the current element pointed by j and put it into our map. We check if we need to shrink the window. Do we have an extra character? Yes, we do. So we remove I and we move on the pointer I to the next index. Finally, we increment j. At this point also we did not find. Map 1 and map 2 are identical. So we increment j. We put d into the map and we shrink the window as well because D is not present in map 1. So this goes to 0, I goes to the next index, and J also goes to the next index. So far we have not found anything. What happens now? In map 2 we increment B to 1. We process J. Do we need to shrink? No. This time we do not need to shrink because we have a character B which is also present in map 1. And the count is also identical. It is less than or equal to whatever is there in map 1. So we do not do anything. We do not have an extra character. Great. We do not need to shrink. Let's compute the result. Are the maps identical? No, they are not. So we move on. And finally we increment J. We process the current element. So A goes to 1. Do we need to shrink the window? No, we do not have any extra characters in map 2, which is not there in map 1. So no need to shrink the window as well. Computing the result. Now this is where we check map 2 and map 1 are identical at this point. Hence we return true. I hope the dry run makes sense. We'll talk about the time and space complexity when we code it up. So let's code it up now. We'll start by taking two vectors, storing the character count for each of our strings. Since we have been told that S1 and S2 consist of lowercase English letters only. So count 1 corresponds to S1 and count 2 corresponds to S2. Let's initialize our pointers I and j, pointing to the start and end of a window. And let's take the size of string S2 as well. Let's populate count 1 with all the characters present in S1. And here is where our sliding window logic starts. So let's follow the steps that we wrote in the skeleton. We'll start by processing the current element, which is pointed by J. We'll put it into our map. We'll shrink the window until we have extra characters. So we'll define the helper function later on. For now, just assume that it returns true if we have an extra character in the current window, which is not present in count 1. So we'll start shrinking from left. That is, start removing characters pointed by I. And we'll increment I. Finally, we'll check if both the maps are identical. If they are, we return true here only. Finally, we'll increment J. And if we never hit a condition wherein both the maps are identical, we'll come out of it eventually and we'll return false. Let's define the helper methods, starting with extra char count in 2. This will tell us if we have an extra character count in the map 2, which is not present in map 1. So we'll loop over every character, every possible characters from A to Z. That is the size of this count vector. We'll check if at any point we have a count in count 2 which is greater than count 1. This means that we have an extra character in the second map, which is not there in the first map. We return true. Finally, we return false. If we never hit that condition, we come out of it, we return false. Let's write the other helper method, which checks if the maps are identical. So we'll loop over every character again from A to Z. At any point, if we see that the count is not identical for a particular character in both of the maps, we return false. Finally, we return true. If we never hit that condition, we come out of it, we return true. So this is our entire code. Let's try to run the example test cases. And they pass. Let's try to submit our code. And it gets accepted. Great. Let's quickly discuss the time and space complexity. So starting with space complexity, we are just taking two vectors of size 26 and we have a bunch of variables. So space complexity is constant, big O of 1. How about time complexity? Let's say our string 1 is of size n1 and string 2 is of size n2. We start off by traversing every character of string 1 and put it in count 1. So that will take a big O of n1 time. Okay. And then there is our sliding window logic. Now the beauty of sliding window is we'll end up traversing or visiting each character at most twice. One to put it into our map, one to remove it from our map. That's it. It will be visited by j once and it will be visited by I once. So at most twice. So this is again a linear time. This will take n2, big O of n2 time. Now you might be asking, how about these helper functions which loop over the count vectors which are of size 26. Since they are of fixed size, we can assume that they run in constant time. So time complexity in the end would be big O of n1 plus n2, where n1 is the length of string s1, n2 is the length of string s2. I hope you found this video useful. Don't forget to like and subscribe for more such videos. I'll see you guys in the very next one.